Number 19. How far will the car travel before its string unwinds? So this is just a simple question asking, as the string unwinds from the drive axle, how far is the car going to go? So at this point, my drawing has been drawn on so much you may not be able to see what's going on, but this is where the rubber band starts to stretch. This is where it's fully stretched. What this means is that 0.1 meters of string is going to be wrapped around the drive axle. When that 0.1 meters of string pulls off, because the rubber band is going from here to here, the car will have gone as far as it's going to go while it's accelerating. So the question is, as that string is unwinding, as 0.1 meters of string unwinds, how far is the whole car going to roll? And we can figure that out by, if we know the circumference of this, then we can figure out how many rotations this wheel will make as 0.1 meters of string unwinds. And if we know how many rotations this makes, and then we know this circumference, we can figure out how far the wheel is going to roll. So first, the drive axle circumference, 2 pi r, 2 pi times 0.0003 meters. That's not right. Should be 0.003 meters. I think I did this correctly, but I just wrote the wrong number. And that gives you 0.019 meters. That's the circumference of the drive axle, really small circumference. So according to the diagram, 0.1 meters of string unwinds. 0.1 meters of string forms one wrap, or sorry, 0.019 meters of string, that's the circumference of the axle, forms one wrap around the axle. So to wrap it around once is that much string. So if we have this much string, how many wraps are you going to get? What I would do is I would say 0.1 meters divided by 0.019 meters, then you get 5.26. So that means this is the amount of string to make it rotate once. This is the total amount of string. There are 5.26 of these in that. Now here's maybe a more careful way to write that. One rotation per 0.019 meters of string. Multiply that by 0.1 meters of string and you get 5.26 rotations. Basically though, I think the more common sense thing is to take the total length of string and then divide it by the length of string for one rotation. That gives you the total number of rotations. Once you know that the wheels rotate that many times, then you need to see what's that going to translate into in movement of the car. How far is a point on the outside of this wheel going to move if this whole thing rotates 5.26 times? So if this axle is rotating 5.26 times, this is attached to it and it's rotating 5.26 times. To figure that out, we figure out the wheel circumference, 2 pi times 0.03. 0.03 is the drive wheel radius. You get 0.19 meters. 0.19 meters per rotation times 5.26 rotations gives you 1 meter. So as this string pulls off, this is going to rotate, a point on this is going to move 1 meter and it's going to move the car 1 meter.